Hello and welcome to another instructional video. Today we are going to be talking about mathematical practice number 4, model with mathematics. What is a model? Our text says models are representations of abstract math ideas. Through numbers, symbols, objects, diagrams, and graphic representations, ergo charts, tables, and graphs, we are able to see and manipulate math concepts and operations. Modeling takes practice to be able to convert math concepts to multiple representations. I want to emphasize the importance of supporting children in using multiple representations so they can construct deep understandings of mathematical concepts. One strategy to help children use multiple representations is using the concrete, pictorial, abstract approach, where we show the problem all three ways. Let's see what this looks like in practice. So I'm going to start out with a problem using crayons. Now I'm going to start out with the concrete representation of my word problem. And my problem is Ryan had 3 yellow crayons. 1, 2, 3. And he had 5 orange crayons. 1, 2, 3, 4, 5. And the word problem question is, how many crayons did Ryan have in all? So I've created a concrete representation with actual crayons. Let's see how many I have in total. Count with me. 1, 2, 3, 4, 5, 6, 7, and 8. So that is our concrete representation, and I was able to figure out that I have a total of 8 crayons. Let's try solving this problem with another method. Let's try pictorial. So instead of using the actual crayons, we're going to draw crayons. Now, children typically, when they model something, they want it to look like the real thing. So if I'm going to draw those yellow crayons, I might use a yellow crayon. So let's do this. So I started with 3 yellow crayons. 1, 2, 3, and I have to draw 5 orange crayons. 1, 2, 3, 4, 5. Let's get those triangle tops on there so they look like crayons. Now this might be a problem that you might have your first graders solving at some point. Okay, so I have my 3 yellow crayons, 5 orange ones, and let's now count it up. Let's see how many total. Get my marker. So we have 1, 2, 3, 4, 5, 6, 7, 8. So I have the answer to my question. Ryan has 8 crayons. Okay. Now, that's one pictorial representation. Just so you know, this would be right too. 1, 2, 3, yellow. And maybe I put a Y there. 1, 2, 3, 4, 5, orange. Add those together. That's 3. And now I'm starting to get into abstract. Let me not get there yet. We'll save that for the next paper. So let's then go to 8 crayons total. Okay, and finally, let's solve this the abstract way. Now, might be one that we're pretty familiar with. We might say 3 crayons plus 5 crayons is equal to 8. Now, as a college student, this might seem pretty obvious that, oh, well, maybe let's just go right to the abstract. But the underlying problem is that students, think of our first graders, they don't have that number sense. They don't have that. They can't do this mental math of 3 plus 5 plus 8. So they might need that one-to-one representation that we provided in both the pictorial and the concrete method. Okay? I'm going to pause the video for a moment here, and we're going to repeat this with a fairly common math manipulative called base 10 blocks. So join me after the pause. Okay, welcome back now. So I've taken out some base 10 blocks. I think these are plastic ones. Some schools have wooden ones. It's a way of showing, way of representing, sometimes we call this a concrete representation. If I say this is 1, this is equal to 10. If I line up 10 of these, you'll see that they are equivalent. Okay, this is really important that they match up. Okay, so both this stick, or usually some teachers will call this a stick or a rod, and these are ones or singles. And then if we took 10 of these and stacked them all together, it would form a 100 block right there. So if let's do another word problem. Let's stick with crayons, and we'll say Ryan had 6 crayons. So I'm going to count out 6 of these blocks. I'm going to place them on this one section. 1, 2, 3, 4, 5, 6. That shows his 6 crayons, a concrete physical representation. Now, he's going to get some extra crayons from his friend Tom. And Tom has 7 crayons. So we're going to go 1, 2, 3, 4, 5, 6, 7. Okay? Now, before I bring those over to my chart here, you'll notice that I have ones, tens, hundreds, and thousands. So here we're trying to practice place value. And the rule is I can't have 10 of anything in any category. I have to trade it if I get a 10. So if I have 10 ones, if I have 10 tens, I then need to trade it for 100. Okay, so I have 6. So let's line these up. So that's 6, 7. Oh, sorry. That's 6 right there. 1, 2, 3, 4, 5, 6. And then I'm going to add those 7 to it. But I want to pay attention once I get to 10. So that's 6, 7, 8, 9, 10. I'll leave that there. 1, 2, 3. Okay. Now I can check to make sure that that is 10 with this 10 stick right here, that rod. And what I'm going to do is I'm going to place that in the tens column, and I'm going to trade that because these are equivalent. I'm going to put those back. So I've solved my math problem of Ryan having 6 crayons, Tom giving him 7, and those add together to be a total of 13 crayons. Let's try that again in a pictorial form. Okay, now this time I am not going to use the blocks. Instead, I'm going to draw them. And your students might want to draw these as cubes. 1, 2, 3, 4, 5, 6. Okay, and then let me keep going. 6, 7, 8, 9, 10, 11, 12, 13. So let's make sure I have, so Ryan had 6, so 1, 2, 3, 4, 5, 6. So maybe I'll label that with an R. Tom gave him 7. 1, 2, 3, 4, 5, 6, 7. Okay, so those are Tom's. And now remember, I can't have 10 of anything in any of these columns. So I'm going to go to 10. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this section right here now is a 10. So I'm going to cross that off. And instead, I'm going to draw it over here as a rod. Okay? And then I have my 3 1s left over here. Maybe I'll rewrite them over here, but I'm going to cross them out so I don't get confused. 1, 2, 3. So if I take 7 and I add 6 more, that gives me 13. And I can see that I have 1 10 and 3 1s, showing that 13. Now, another way that students might show this, sometimes they might just draw dots. Okay? And what's happening is, throughout this process, we're getting more abstract. So even that first step, if we come back for a moment, and so they might do dot. Let me just finish this one. 3, 4, 5, 6. So those are Ryan's. 1, 2, 3, 4, 5, 6, 7. Okay, let's count 10 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So maybe this group, I'm going to X out, and I'm going to just put it over here. Some teachers might show that as just a line. Okay, but even this one, which was our concrete example, this still is slightly abstract because remember, we don't have the crayons. So depending on where your students are at, we might, the level of abstraction might be more or less. Now, if we go to fully abstract for that problem, let's say Ryan, Tom, 6 crayons. Tom had 7. 6 plus 7 equals 13. Now, instead of just having students do this one way, it's especially powerful when we ask them to do it all 3 ways. Can you show me, or maybe can you show someone at your table how to solve this in a pictorial way? Can you show me how to solve this in a concrete way? So we want to give children multiple opportunities to solve the problem in different ways. By doing so, remember I said before, it helps them construct that deeper understanding of the mathematical concept. Now, this is just one way. I've done it with the base 10 blocks, the crayons. These are just 2 ways to model. We could also be modeling with graphs or tables. And we're going to do some of that in the class. You're going to actually do some of that to practice. So thanks for learning with me, and I'll see you next time.